presenter, I would like to invite Guo Ren. He's a staff engineer at Alibaba, and he will talk about the innovation features of RISC-V Linux V3 patch.
Okay. 2番目のスピーカーはゴーレンさんです。ゴーレンさんは Linux システム
什么
Linux GSKY maintenance をやってらっしゃいます。Dr. Koshi-san, please go ahead. Oh, yeah. After presentation.
Yeah. So,
just a normal presentation mode.
it's clear.
Let's speak in
右クリックが反応これかあれ
I don't know what's happening. Presentation. Okay.
just use twice to checking out the
Okay.
use.
I see.
So it will be use presenter tools.
Yeah.
Okay.
Thank you.
Okay, please go ahead.
Hello. Yeah. Hi everyone. My name is Guo Ren. Come from China, and I'm a Linux subsystem maintainer. And today I will share my work, have a technical deep dive of the RV64ILP32 Linux kernel patch set. Okay. Let's continue. This is the presentation agenda. We have a quick recap with the RV64ILP32, and let's see what's the innovations, key features of the version 3 of the Linux kernel patch, and then I will give the demo and welcome the question. Let's see what's the traditional ABI. Traditional ABI now we contain about the ILP32 and ILP64. The ILP32 is based on the 62-bit ISA, and currently RISC-V don't give out any profiles about the 32-bit ISA. And now the RISC-V International are focused on the ILP64 ABI and based on the 64-bit ISA, such as the RVA profiles 22 and 23. This is a traditional ABI definitions. And what's the 64 ILP32? That means we could running the ILP32 ABI on the 64 on the 64-bit ISA. That means we can run the smaller ABI on our released RVAB profiles hardware, existing hardware and shipped out hardwares. So that's the what the 64 ILP32 ABI is. Why we need this ABI? There is a very famous film in history many years ago. It's mentioned by the Nusi. He is the Turing Award owner. Yeah, and he have said, it is absolutely idiotic to have 64-bit pointers when I compile a program that uses less than 4 gigabytes of RAM. Yeah, when such point values appear inside a structure, we not only waste half of the memory, they effectively throw away half of the cache. So, if you using the 64-bit ILP64 ABI in a embedded world or in small resource-efficient world or in unnecessary address space scenarios, you would waste memory and decrease the performance of the computing. So that's what he said. And then x32 ABI come out with the Intel x86 in history. And why you would find let's look at the right table. And you would see the traditional 32-bit ISA of the x86 is very different with the 64-bit version. And they have different register numbers, and they have different register ways. And the instruction OP code are different. Instruction set are different, such as from float point to the SIMD instructions. There are a lot of difference. So if you use the RISC-64ILP32 ABI, then you can utilize the more powerful 62-bit ISA to improve your program performance. And you will see that they have some they have monopoly some benchmark. They gain about 40% faster than the LP64 applications, because this new ABI have a smaller cache cost, and the cache improvement could help with the performance. And average, you will gain about 5 or 8% faster than on average. That's why history requirements of this ABI. So what about the RISC-V? Let's look at the instruction definitions. RV32, we have defined RV32 and RV64 in a uniform OP codes. That means the RV64 contains all the instructions in functionality of the RV32. And that means the RV32 functionality is perfect for the RV64. That's very different from the ARM and x86. And second, RV64 instructions could significantly improve performance compared to the RV62. Because RV64 ISA have more instructions, have wider load store instructions that will help in performance. Yeah. So RV64 ISA is more powerful than RV32 in RISC-V. Let's see what we can gain from RV64. Yeah. And if we're using the RV64 ISA to gain more performance than RV32 ISA, because we have wider registers, and the register is the most important for the performance of the computing hierarchy. If we can utilize this register 64-bit register, wider registers, we can gain more powerful performance. And in the right side, I have a comparison of the RV64 ILP32 and with the traditional ILP32. When we keep the same memory footprint with the traditional RV32, we gain 7% improvement in the performance and faster than the traditional 32-bit ISA in the iPerf loopback. And you can gain maybe 20% faster than in the FIO RAN disk. And you will find widely and significantly improvement in the LM bench. Yeah, and the yellow color is tell you is tagged the performance improved more than 10%. So you can see more than 50% of the cases have the improvement of the performance. So that's the power of the RV64-bit ISA. So why RISC-V need the RV64 ILP32 Linux? Because current RISC-V only released the RVAB profiles, which based on RV64-bit ISA. And then many of the chips have produced that based on the RV64-bit ISA. And here I have put them here, and in the future maybe they have more than these chips. So from market view, they need a ILP32 solution to help them cost to gain the better performance, to decrease the memory footprint cost. So that's why we give out RV64 ILP32 solution, the Linux. And all these chips now, if you bought them from the market, of the development board, and you will see they all running the Linux, and they are running the 64-bit Linux, and which is very waste memory. So that's the motivation of this work. I began this work in the 2023, 2 years ago. I have two versions of this patch set. I give out the patches. I firstly based on the traditional 32-bit Linux configuration, and I also support the RV32, ILP32 ABI user space ecosystem. I also introduced a new user space RV64 ILP32 ABI based on the RV32 system core. And then I get a lot of downside feedbacks from maintainers. I have talked with the architecture maintainers such as Anne Bergman and Linus Torvalds self. And I got these feedbacks, and I found out that, again, one thing, the 32-bit configuration is going away in Linux. And people, the guys in the Linux world now are removing this configuration. That means 32-bit is going away. I'm getting a wrong boat, and this boat is shaking. And also the RV32, ILP32 ABI user space is also shaking. Is not is have a very black future. And many people don't like a new user space ABI. So that's I have gained from my first two versions of the work, and then I changed the work. I changed the patch set, and I have a very deep modification in the version 3. So let's see what's the innovations in the RV64 ILP32 Linux kernel patch set, version 3. I haven't sent it out. It's still on my computer, but I will soon send it to the mailing list. And today I will show you the demo and running it and for you, and let you see what's happening on this version. The first key features is that now I'm based on the configuration of the 64-bit. That means I'm not a 32-bit from Linux kernel view. I'm a 64-bit from software design. Second, sorry. Second is okay. And the second is it could support traditional LP64 ABI user space ecosystem. That means you can directly run the 64-bit user space on RV64 ILP32 kernel. Small kernel, but with a small ABI kernel, but it could run larger ABI user space. And we comprise the 64-bit user space applications into 2 gigabytes address space. I will show the demo next. So, compared to 64-bit Linux, Yeah, this is the RV64ILP32 ABI, and this ABI have adopted by the PS ABI specification RISC-V recently. It have merged, so it's released. It's a formal ABI in the RISC-V. Okay, compared to 32-bit Linux, okay, we can support 64 ABI user space. And you will see all these features that depends on 64-bit in Linux kernel. And I didn't list all of them because 32-bit in Linux kernel is very limitation, have a lot of limitation. A lot of features cannot be used. But this ABI Linux kernel code has the same feature, has the full functionality with the 64-bit Linux kernel. So that's the key features of this version. Now I will give the demo and let you see how we running the 64 ABI user space on the RV64ILP32 Linux kernel. Okay. Here is this. I use the QEMU. And this QEMU is a 64-bit QEMU, right? And we will import the kernel and keep the same OpenSBI and keep the same rootfs, the rootfs 64 ILP32. Okay. Oh, sorry. I will change. Sorry. Sorry. Okay. I cannot. Hello. I cannot put that window on. Let me see. What I don't know. Sorry. 系统设置，屏幕设置，屏幕。好，这个是。OK， 这个奇怪。OK. Okay. Now I will give the demo that we use the QEMU, yeah, the 64-bit QEMU, and the OpenSBI is the same, and we use the 64-bit rootfs, yeah, and you can see now I can directly run the image. This kernel is ILP32 images, yeah, and then it's called normally. Bring up, and if you look at the memory consuming, yeah, the memory consuming is there, yeah, it's about maybe 11. Okay. Sorry, this. I don't know what's in it. Yes. Yeah. Oh, okay. I will small it. Yeah. And you will see it costs about 11 megabytes, the memory, right? And if you see the maps, 64 bits maps, you would see it works on the 2 gigabytes address space, and it's used the whole 64-bit user applications, and you can see the I give MDiv. So the MDiv is here, right? So let's let's compare it with the traditional 64-bit kernel, yeah. And also sorry, Oh, because in the right hand I still use the RV64ILP32, so I need to close it, and then I can run it. Okay. This is a traditional 32-bit ISA, yeah, and you would find out that the memory is about 15 megabytes. And the last time we have in the left side, we only have the 11, yeah, and from 11 to 15, you know, the root interface is the same, the kernel configurations is the same, the OpenCPI the same, and the total memory is the same, but the used memory increased about 4 megabytes. It's more than 20% memory saved. 20% memory saved if you directly use in your current developed board. And look at let's compare it. Look here, and the MDIV sum is the same, so the root interface is the same. And if you look at the maps, you would find 64-bit user space working in a larger user space address space. But we made the 64-bit applications in only 2 gigabytes, so that's why it saves memory. So you needn't change anything. You just exchange your image. Then you can use it in your current developed board. And this version could serve all these boards. All the boards, if your physical memory is less than 1 gigabyte, you can directly try this version 3. And it could compatible with your current 64-bit user space. That's all. Thank you.
So thank you very much for the talk.
Hello. I'll get close to you because I don't think you can hear the speaker.
Yeah.
Between V2 and V3 of your patch set, did you have to eat any performance regression from adding the 64-bit ABI support?
Okay. Actually, the performance is the same. Oh, yeah. The version 2 and the version 3 have the same performance. But the difference, the version 2 is based on I mentioned the most important is the base version 2 is based on the config, it's based on this one. It's based on this one. Yeah. Yeah. But that's the wrong bot. Yeah, because this world don't like this configuration. They want to removing it. I found out. I found out I'm in a wrong bot. So in version 3, yeah, what I put the most effort is I make it on 64-bit. So I got a new board. This new board is about future. It's bright future. So I just make the ILP32 could run on the 64-bit configuration. And actually, in history, no architecture have tried this work.
Oh, interesting.
Yeah. Okay.
Well, it's Linux maintainer stuff.
Yeah.
I guess it makes them happy, which is good. Also, is it possible to address more than 4 gigabytes of memory under the 32-bit ABI, or is that a hard limit?
Pardon?
Is it a hard limit to address less than 4 gigabytes of memory under the 32-bit ABI, even running on a 64-bit chip?
Firstly, we didn't introduce any user space ABI, so we haven't large test on the user space of this ABI. And what we do is compatible with existing ABI, such as LP64-bit ABI. And we just compile the Linux kernel itself into the 64ILP32 ABI. And in this range, we don't find any gap about you have mentioned addressing problem. Yeah, and I think the compiler maybe would pay a lot of work on this way. Yeah, but currently it's satisfy my current implementation. I can make it work. Just give you the demo. If the problem you have mentioned, that demo would crash.
Right.
Yeah.
So a user space program can access the entire address space of memory, right?
Firstly, I've said Linux don't like the new user space ABI, so I won't introduce this ABI currently. But in the future, I would reuse just like this. I would reuse the. I will see that. Yeah, I would reuse LP64 ABI. That means if in the future I would build the whole RV64 ILP32 ABI ecosystem, if people want to build that, you just reuse the traditional 64-bit ABI. It's enough. And you needn't introduce any new ABI for Linux. Yeah. Okay.
Understood. So there's no new user space ABI yet.
Yeah.
Right. There's no new user space ABI yet, is what you're saying.
There is no user space RV64 ILP32 ABI ecosystem currently. We didn't start this work.
Right.
But maybe in the future, I think that's what we are different from the traditional architecture, such as x86, such as the ARM, such as the MIPS, such as the Spark. We are different. We start point is the supervised mode. We make the supervised mode built with this ABI. But the history architecture, they directly built the user space ABI, but they all failed. No popularly used.
Right.
But we started this point on the supervised mode and make the RTOS, make the Linux kernel to gain the revenue, gain the benefit from this ABI. That's our start point. And the next, we will spread it to the user space. Okay.
Thanks. I understood your points.
Yeah.
Thank you.
Okay, thank you very much. Any other question?